Today on Earth Focus, the impact and politics of climate change. Climate scientist Michael Mann speaks with correspondent Miles Benson. Coming up on Earth Focus.
We will have years like this more often than not, and we've had that for the last 5 years.
And just aren't enough sandbags to go around. Still, not enough sandbags to go around.
I haven't seen a winter like this in a really long time, or even maybe never.
We've been seeing some severe weather. Expect to see more. It's coming. Hurricanes, floods, droughts, raging wildfires, snowstorms, and tornadoes. Is this purely nature, or are there man-made, therefore controllable, factors at work? A warmer, moister environment can intensify storms, creating heavier precipitation. And this, scientists say, is why human activities may account, at least in part, for the rise in extreme weather we are experiencing.
But the debate is settled. Climate change is a fact. And when our children's children look us in the eye and ask if we did all we could to leave them a safer, more stable world with new sources of energy, I want us to be able to say, yes, we did.
As the Obama administration renews its commitment to act, the debate over climate change remains polarized. Climate scientist Michael Mann is a central figure in that debate. He was one of the scientists behind the development of the controversial hockey stick chart, which showed how temperature in the late 20th century was exceptionally warm compared to the previous 900 years. This triggered attacks on Dr. Mann and the science behind his work, all documented in his book, The Hockey Stick and the Climate Wars. Michael Mann, you write that in mid-1990, scientists were able to begin to connect the dots on climate change. Could you elaborate?
We understood the basic science of the greenhouse effect nearly 2 centuries ago. Joseph Fourier, the same guy who discovered the law of heat conduction, understood that there was this greenhouse effect. So we've known for some time that the greenhouse effect exists and that we're increasing it through fossil fuel burning. By the mid-1990s, we had reached a level of formal certainty about that we had not before reached. We could actually attach a number to it. In the second assessment report of the IPCC, published in 1995, the IPCC concluded that there was now a discernible human influence on the climate. Now, there's an interesting story there. The language would have been stronger than just discernible, but the delegates of certain participating nations like Saudi Arabia demanded that the language be watered down, and discernible ended up being sort of a lowest common denominator. It was the one thing that everybody could agree on, the governments and the scientists. But we were able to say that we've seen the fingerprint now of human influence in a formal way. We could actually detect that human fingerprint in the patterns of climate change that we had measured.
Given the seriousness of the issue, can you explain why there has been so little action by policymakers?
Well, unfortunately, many of our politicians are beholden to fossil fuel interests. I mean, let's make no mistake here. We're talking about taking on the most powerful industry that ever existed on the face of the earth, the fossil fuel industry. They've chosen to fight back using hundreds of millions of dollars, for example, in the US, to fund what, without exaggeration, is the greatest disinformation campaign ever run. In fact, there was a memo that was published in 2002. Actually, it was leaked. It was a leaked memo from a Republican pollster named Frank Luntz, and he was advising his clients, essentially fossil fuel interests. that back in 2002 there was this closing window. The public was now becoming convinced by the scientific community that human-caused climate change is real. And if they were to become convinced about this, they would demand policy actions be implemented, action be taken. But what Luntz said was that there's still a window of opportunity left, according to his polling, according to the focus groups that he had done, to confuse the public, to cloud their understanding of the issue, to try to make it seem as if the science is still fiercely contested. And what he said was, as long as the public thinks that scientists don't agree, that there isn't a scientific consensus, they can be convinced that it might be too costly to take action. And so that's exactly what the forces of climate change denial have chosen to do ever since. They've doubled down, if you will, in this campaign of disinformation.
I want to do my part on global warming. All Yes on 23 says is...
The effort through television advertising, through the cultivation of so-called experts who attack the science, talking heads, the cultivation of talking heads who appear on talk radio, who appear on cable television. They've created this very elaborate network of think tanks and advocates to create confusion in the public mindset about this issue of human-caused climate change.
So what we're seeing here is a drastic change in climate, aren't we?
Well, climate has always been changing, but this has nothing to do with man.
I have made a case, a very solid science-based case against anthropogenic global warming.
And methinks someone is playing fast and loose with this whole subject.
Yes, they are. I mean, basically, global warming causes less snow, except when global warming causes more snow. And it causes less cold, except when it causes more cold.
If we're going to penalize producers of carbon dioxide, then every time we exhale, we're breaking a law.
It's getting warmer, you know, in Jupiter, and they don't have any SUVs driving around in Jupiter.
They said there were going to be more tornadoes, more hurricanes, no ice in the Arctic, increasingly hot weather. You have to stand up and point out that every year now for 15 years, they've been wrong.
The dreaded polar vortex. Do you know what the polar vortex is? Have you ever heard of it? Well, they just created it for this week.
All they need to do is to convince the public that the science is uncertain. And that's why you'll find some of their advocates who will deny that climate change exists, deny the science altogether, but others who are somewhat more surreptitious in their attack will concede some of the scientific evidence, but will say that there's too much uncertainty, that the impacts might be substantially smaller than what the scientists who study impacts say. So there are these various lines of attack, from denying climate change outright to simply contesting that it's a problem. The only commonality being the argument that we don't need to transition away from our reliance on fossil fuels, an argument that's, of course, very convenient to the fossil fuel interests who are funding all of this disinformation.
You talk about the scientization of politics. What exactly does that mean?
One of the other things that they've done is to co-opt politicians, like James Inhofe, senior senator of Oklahoma, who has declared climate change to be the greatest hoax ever perpetrated on the American people, while it continues to ravage his state, because indeed Oklahoma has been at the front lines of the impacts of climate change on the U.S., the record drought, the record heat that they've seen in recent years. But other politicians like Joe Barton, who is the chair of the House Energy and Commerce Committee, a large number of politicians, sadly, many of them on one side of the partisan divide, Republicans in particular, whose campaigns have been financed heavily by fossil fuel interests and who are now doing little more than acting as advocates for fossil fuel interests when it comes to the question of passing legislation to deal with climate change. That's really that scientization of politics that I was talking about. This idea that the underlying scientific evidence is just a political football to be contested as would any other political issue would be contested, and there are politicians whose job it is to contest that evidence. When in fact, that's not the way science is. There aren't two equally valid sides. There's a reason that the Flat Earth Society no longer prevails in our public discourse, because they were wrong. The Earth isn't flat. We accept that. Gravity does exist. There are propositions in science, and I'll tell you, if there was a vested interest, if there was a huge industry that would stand to profit greatly if the theory of gravity were wrong, you would see the theory of gravity being contested in our U.S. Senate.
Talk about the hockey stick and why it became such an icon in the climate debate.
Well, it's this curve that my co-authors and I published now 15 years ago. We attempted to estimate the temperature of the Earth back in time. Now, there's only about a century of widespread thermometer measurements around the world. So we can only document from instrumental measurements, thermometers, how the globe has warmed over the past century to a century and a half. And we know it's warmed about 1 degree Celsius, about 1.5 degrees Fahrenheit. What the instrumental record can't tell us is how unusual is a warming like that over that period of time. Could it be that that sort of warming happens naturally over a century time scale? To try to address that and related questions about how the climate had changed in the past, my co-authors and I attempted to make use of what we call proxy climate records. Natural archives like tree rings or corals or ice cores or lake sediments that tell us something about how the climate changed in the past. And often these records are available not just 100 years, but 1,000 years or even further back in time. And so we took all of the information that was available at the time from records of this sort, so-called proxy records, to estimate how the temperature of the Earth, specifically the northern hemisphere where we had the most data, how the temperature of the northern hemisphere had changed over the past 1,000 years. And what we found was, although the estimates are uncertain, as you can imagine, because we're not working with thermometers, we're working with these very imperfect natural thermometers like tree rings and ice cores. So there's this band of uncertainty. But even when you look at the band of the uncertainty back in time, you see that the recent warming is outside of the range that we see over the past 1,000 years. There's no evidence that a warming of this magnitude happens naturally, at least as far back as we could go. It led to a chart which depicts temperatures starting out fairly warm 1,000 years ago, getting colder as you descend into the depths of the Little Ice Age, and then, of course, the rapid warming of the past century, the spike at the end. And it was the shape of this long-term cooling followed by this rapid spike that sort of resembles a particular sports implement, a hockey stick, and it got named the hockey stick. The curve was featured in the summary for policymakers of the third assessment report of the IPCC, the 2001 report, and it quickly became an icon in the climate change debate.
Are the severe weather patterns we're seeing today related to climate change?
We are seeing sort of the loading of the weather dice, is the way I describe it. You can't look at any one heat wave and say, climate change caused that particular heat wave with any great degree of certainty, because there's a lot of sort of natural variability in the weather, the vagaries of the weather. You can get unusually hot days just from chance alone. You can get unusually cold days from chance alone. One of the things you can do is tally those rolls. So these are random rolls of the weather dice. And the question is, are we loading those dice so that sixes are coming up more often? Well, it turns out sixes, by some measure, are now coming up twice as often as they ought to. And what I mean by that is if you look, for example, at the US, and you look at the rate at which we are breaking records for all-time warmth, and you tally over all of the locations across the country, all of the days of the years for all of the 100 or so years where we have good data, and you look at how often we are breaking all-time records for warmth versus all-time records for cold, okay? In an unchanging climate, in the absence of human-caused climate change, that ratio should be 1 to 1. You should break cold records as often as you break warm records. What we're seeing is we're now, if you look at the past few years, for example, seeing warm records, all-time heat records broken at 3 times the rate. Cold records are being broken 3 times the rate you would expect from chance alone. That's actually like rolling sixes 3 times as often as you would expect. So rather than rolling a 6 1 in 6 times as you would expect from a fair die, sixes are coming up half of the times. Every other roll is a 6.
Is climate change happening faster than we expected?
The current trajectory that we're on leads to the conclusion that within a matter of a couple decades, we may see ice-free conditions in the Arctic at the end of the summer. This is something that the climate models predict shouldn't happen for another 60 years, till the end of the 21st century. And indeed, nature seems to be on a course that's faster, that's more dramatic than what the climate models predict. We are already observing and measuring a decrease in the amount of ice in the Greenland ice sheet and the West Antarctic ice sheet. Now, the climate models have predicted that we shouldn't see that for many decades to come. And a key distinction here is if it's a land ice sheet, a land-based ice sheet, then when it melts, it actually contributes to global sea level rise. That's not the case for sea ice, but it is the case for the continental ice sheets. And so the fact that we're already measuring losses of ice from these major continental ice sheets means that they're contributing to sea level rise faster, once again, than climate scientists projected them to.
Can we say how soon it's going to start causing problems for people who live near the seashore?
There's a credible body of work now that suggests that if we continue with business as usual fossil fuel emissions, then by the end of this century we could see as much as 2 meters, 6 feet of global sea level rise. Now that would be catastrophic for many coastal regions, for the US East Coast and Gulf Coast, island nations around the world, some of which will literally be submerged by that amount of sea level rise. The IPCC makes a far more conservative statement. They state an upper bound of about 1 meter, about 3 feet. And it's once again an example of where the IPCC arguably has been overly conservative. Some, as myself, have argued that partly that's just due to the culture of science. Scientists tend to be reticent. We don't like to make strong conclusions that we have to withdraw at some later time. And there's also a component, I believe, due to the pressure, the outside pressure, the critics, a very well-funded and well-organized effort to literally discredit the science of climate change, sometimes by attempting to discredit the scientists themselves. I myself have been a victim of that. And in the face of all that pressure and those attacks, I think to some extent the IPCC has actually withdrawn a bit, and they've been more guarded, more conservative, more reticent in what they're willing to conclude than they really should be given the evidence. Arguably, if it is indeed the IPCC's role to advise governments on the potential for dangerous anthropogenic interference with the climate, which is what the IPCC was originally charged with as their mission. Arguably, you should not sort of downplay the higher end scenarios if they're credible, even if they're low probability outcomes. Mitigating climate change, doing something about our carbon emissions, is a planetary insurance policy. And in guiding the terms of that insurance policy, we need to be focusing on some of those potential more extreme catastrophic outcomes. If the IPCC systematically downplays those outcomes, then it doesn't serve that larger process of societal risk assessment as it should.
If the changes are becoming so visible, why isn't the public more readily accepting climate change as reality?
Unfortunately, one of the lessons of sort of battles over environmental protection in the US this century is that unfortunately, a problem often has to reach crisis proportions before policymakers are willing to act, often because there are vested interests who are lobbying heavily for actions not to be taken. And this was the case, for example, with acid rain, where we committed to far worse environmental impacts of acid rain than we should have, because the coal industry, whose emissions were causing acid rain, fought back fiercely against any policy action to deal with it. Ozone depletion, once again, it took us decades to act. We knew that the problem existed back, in the early 1970s. It took until the Montreal Protocol, 1984, for us to actually take policy actions to prohibit the production of these substances, chlorofluorocarbons, that were destroying the ozone layer. And perhaps the best example was that, the environmental pollution of our lakes and rivers. The Cuyahoga River in Ohio. It took that river catching on fire. It took a river catching on fire for the U.S. public to say, wait a second, we've got a problem here we need to do something about. So some of us, think that we may, unfortunately, need to have that Cuyahoga River moment in the climate change debate before we will act. Something so undeniable that even the most well-funded, well-organized disinformation campaign cannot convince the public not to believe what they're seeing with their own two eyes.
When you talk to other scientists and urge them to get into the fight, do they explain their reluctance?
What I perceive is that this problem is starting to solve itself naturally through sort of generational change. Many of the younger scientists that I talk to, the graduate students today, young postdocs, they grew up in a different environment. They witnessed the attacks on science, and to many of them, it upset them. It upset them that scientists were being attacked for simply speaking truth to power, and it sort of energized them, and they come in wanting to do something about this. I have the sense that there's a much greater enthusiasm for public outreach and communication among the younger scientists that are coming into this field. And it may have been an inadvertent byproduct of the attacks against the science. I think it's actually led to sort of a new breed of scientist who comes in wanting to do science, because that's what we all really love doing, is science, but recognizing that there's also a role for speaking out, for communicating the science.
If we continue our upward trajectory in fossil fuel burning, what will the planet look like at the end of the century?
Qualitatively speaking, if you look at impacts on human health, water availability, human water resources, food resources, land, the global economy, pretty much every sector of our lives, of human civilization, what you see is a business as usual fossil fuel burning scenario by the end of the century gives us highly negative impacts across the boards in all those categories. I forgot to mention biodiversity, a potentially large-scale extinction of species. Some of these we can quantify economically, or we can try to. Some of them we can't even qualify how important they are. What is the value of the Earth? Well, it's infinite, because if we destroy the Earth's environment, there is no plan B. There's no planet B that we can go to. How do you put a cost, on the health of the environment? Arguably, you can't even do so. And in fact, it's that principle, that it's an infinite cost, when we start talking about those sorts of scenarios, that leads some people to conclude that the precautionary principle applies here, that the potential impact of what we're doing is so potentially harmful to us, to other living things, to the planet, that it's almost obvious that we need to mitigate this problem, that we need to take actions now to avert those catastrophic futures, potential futures.
Many people believe that truth will prevail over time. But do we have enough time left?
So there's an urgency to this problem now, unlike any time in the past. And there is still time to avert catastrophe. That's the good news. The bad news is there isn't a whole lot of time. And what it means is we don't have another 5 or 10 years to debate in our U.S. Congress whether or not climate change exists. We have to be debating right now what we're going to do about it.
Michael Mann, thank you very much.
Airwaves, a global channel of uncompromising stories, world news, documentaries, entertainment, and culture. Link TV, connecting you to the world. For more information, visit linktv.org.